Good morning, everyone who join us for this webinar organized by CAiRS, Center for Advances in Reliability and Safety, co-organized by University of Maryland in US, and supported by Hong Kong IE, Hong Kong EIA, FHKI, Science Park, IET, SOE. Thank you for joining us. CAiRS has been here for over a year. It's 100% funded by the Hong Kong government, and the chief executive just announced our existence. We are one of the 28 InnoHK Center or research cluster. So from time to time, we'll organize technical seminar, join together academics and industrial friends who will be delivering topics that are of common interest to the industry. We have been organizing 4 technical seminars in the past year and 1 whole day technical conference in the past year. So if you want to have a look on these topics, you can always welcome to go to our website. So this morning, as the Center Director of CAiRS, I'd like to introduce to you some of the friends from our counterpart in UMD who will be our speakers, as well as our industrial friends from the industry. Today, this topic is named as Reliability and Failure Analysis for Electronics. Now, as we all know, electronics play a very important part in our industry as well as in our daily life. Now, failure is not something what we want, and reliability is something that we want. So this morning, we have 3 speakers, including academics and the friends from the industry, who will be sharing with us what's the latest trend and the applications for reliability and failure analysis for electronics. We are glad to have someone from the industry who will give us information about how he applied reliability and failure analysis in his own company. So next to me is Mr. Alex Chen, who is the General Manager of Tronico Technology Company Limited. So the topic he will share with us is reliability and safety for IoT system. Now, I suppose many of us who know IoT devices and systems are now very helpful or even critical, not only in industrial applications, even in household applications. Now, particularly, it will be very critical to the development of smart city. So I'm glad to have Alex on my left-hand side. So I hand over the time to Alex. Alex, please.
A gentle reminder, if you are invited to join the private session, please click another link to join us. Thank you. Mr. Alex Chen, please.
Thank you, Professor Yong. So today I will talk about the IoT products, reliability and testing. I think all people can see so many IoT and smart solutions over the world or in Hong Kong as well. So I think this topic is very important because you will facing so many different kind of IoT or smart solution in your life, and you will see some problems and you don't know how to solve it and why having it. So today's topic, I will talk about this and how to prevent and how to do some analysis of this before you see the problem happen to your face. First of all, let me some introduction about our company, Tronico. So we from the AMC group. Excuse me. So, AMC is a factory, 50 years Hong Kong factories in Long Kong, in Shenzhen, in Malaysia, about 3,000, 5,000 people. So that's why we basically have a factory background company, but also not only about the manufacturing and product development, and also we have a software team in Science Park in Shenzhen, Science Park in Hong Kong, more than 7 years. So that's why we have a product, software, and also cloud development in Hong Kong as well. So that's why it's very important. So we proposing one single provider solution for whole IoT and smart solution to our customer. And you will see we have so many project reference, and we have 1,000 of the IoT is running in the cloud, and so we have so many reference about the project on IoT and smart solution. So it may help to really understand the quality and safety issue that we encounter and present to you today. And the last one you can see is we have some awards and over the last few years. So, and next page. So from our experience, so there's 5 quality factors. It's very important in the IoT or smart system. The first one is the product quality. So individual products, how to make the quality and safety is important. This is the first one. The second one is a system. So instead of one product or 2 products, is we combination of the multi-product, and we have a gateway or cloud or networking apps. So whole these things will become a system. So that's why we not talk about the standalone product. We talk about the whole system quality. I think this is a new topic in IoT solution on the quality and safety. And next one will be implementation. I think so many people maybe ignore the product is very important, or the system or cloud is very important, but actually we find so many projects. The IoT implementation also is very important, especially installation or the production in the manufacturers. Also, it's very important part of the quality control. And wireless, this is very special because usually wireless quality may not be under the product quality, but in IoT, the wireless will really becomes very important topic for the quality and safety control. I will talk about it later. And the last one will be the cloud. So I think last few weeks, so you see the Facebook have a cloud problem, or even we heard so many news about the cloud issue that impact to your life. Even you cannot open the door because the cloud failure. So that's why the cloud quality or safety also is very key factors of the whole smart solution and IoT solution. Okay, so these 5 factors, actually we execute in a very important project in Tronico. And this is the smart hotel project, more than 1,000 guest rooms. And that consists of lighting, thermostat, and curtain control and sensors, and some scenes panels. So all the rooms will involve so many IoT products inside the project. So that's why there's 5 factors. It would be very, very important how we can control the quality on these 5 areas. And you can see this is an overall picture for each hotel rooms. So you can see different kinds of IoT products or wireless products is involving in this project. You see sensor or the Google Home voice control, or the lighting control, power control, and gateway scenes panel. So all these factors is going to inside all the hotel or residential, even commercial project as well. The first one I would like to talk is the product quality. The products, the track point, you will see the factory. So actually, the factory, why so important is they have to comply to the standard procedure, let's say ISO. So they must, all the people doing something in the international level, in the process, in the record, all the data should be under control by the international level. This is very important for the factory as a standard. And the next one will be the compliance. So I think each product also is an international level of the compliance of the safety and the product quality level. This is also is very important on each product. And the third one will be about the reliability test. So I still remember all our products before I understand the factory reliability test. But now I inside the Tronico, so I know that so each product will be consistent, including about 36 and 40 reliability tests on each product. So it's a whole series of the testing involving on each product. We have to pass it before send to the customer. And the third one will be functional. So this one will be based on each product categories and the functional spec to understand each product function and then to do specific testing on the function level. Why I put it individual? Because usually factory not always doing the functional test for product, because product stand alone should be reliability test, but some product will be integrated to system or they will provide some special function into the system. That's why the functional test also important in the factory level. And the next one will be the wireless. This is very special and good topic because wireless quality not always talk about in public, but I will, based on my experience, and let you know about this more. The checkpoints about the wireless. First of all, you have to pick the right wireless protocol because you will see many wireless protocol over the road, Wi-Fi, ICP, LoRa, Z-Wave, or so many. So I think the quality must be based on what kind of the wireless protocol you are using. You're using the indoor wireless protocol or outdoor RF wireless protocol, or this wireless protocol have encryption, and what kind of encryption involved about, and what kind of network architecture they are using. They're using the mesh network, or they're using the long range, low power wireless network. And also, I see some RF frequency. They in different country they will using different frequency, so they may use improper frequency using in that country. That may happen in quality issue. For example, if that frequency using in the mobile phone or walkie-talkie, if this product is installed in this country, the communication or the capacity or even the stability may have an issue because of the frequency issue. So that's why the frequency compliance is very important. And the last one will be the communication range, because as I said, indoor and outdoor wireless will be different communication range and different characteristics of each wireless protocol. So this also is a checkpoint under consideration in the quality and safety. And simulation test is that we have to do it in the factory, not in the application level. What I mean in the application level? Let's say I install the whole product in the house or in the office or in the hotel room. But in the factory, we would not build up the hotel or we not build up the residential as a simulation. But we have some equipment to put the product inside and simulate the situation to have a test of the wireless strings and package loss. All this will be doing inside the factory. And also we would do in the outside area to check the wireless distance. This one also is very important in the factory testing, equipment and testing procedure. On the side, so we have some equipment for the different wireless protocol to understand the wireless, the wireless signal, how good in that application. Let's say in the school or in the home or in the office, and may different application may have a different difficulty or different problems that cause the quality or the safety have issue. And the last one will be the auto test, because once we do all these kind of tests, we done, but finally we have to using the cloud to make sure all the tests automatically to process and generate the report in the cloud, so that not only about the data is good or not, actually the auto test is running all the product and get all the data to make sure the product is running well in this application. And the next one will be the system quality and implementation quality. Okay, first of all, we will do all this product inclusion to our system, and also we will, from the factory level, to define all the product, and the system have an individual address. So it will be a part of the procedure in the factory on the production line. So we define all the product inside the system, inside the cloud, inside the gateway, and provide the address of each product or gateway. And also we will join the system auto test to make sure the system and address or everything is doing right in the production line. And the testing record and the result will be recorded on the cloud. So this is the first part of the implementation of the system. And the next one will be, we have to, as I said, the factory part is one part, and another part is a real actual site. We have to do the whole system, the real testing, and to make sure all the product and the logic or algorithm or the cloud communication will be working fine in their application. And this is the on-site part instead of in the factory or inside the lab. And the next one will be the on-site. We actually install the product on the project location or on the application. So the installation part always would be the people ignore and forget, because actually the installation of the wireless product will be very technical, and also it will big impact of the result of the project. So that's why the installation also is very important part. For example, if I install the motion sensor on the area is not a right location, it may not detect the people occupants in good way. This is a very important. That's why installation, the workmanship also is a very important part of the checkpoint of the implementation. And the last one will be the system automation test. The system automation test is once you done the factory, you done the POC, you done the installation, and you do all the testing, and then the system will be automation testing by the cloud and the gateway to make sure the system is running well in that location, in that application. It will help to make sure there's no people forgot to do something, and the system automation to test it and generate the report, store in the cloud, so we can check it is a pass or fail in the last part of the project installation. The last one will be the cloud quality. As I said, so you will see more cloud issue, and that will impact your life and your project. That's why the cloud quality and safety is very, very important in the future. And you may see we do project on a penetration test and the cybersecurity level, and the loading test to make sure not too many people using it. the cloud will down. So also we have to make sure it will comply to ISO 27001 as a cybersecurity compliance. Of course, the cybersecurity compliance, there's so many different kind of the method and the certification. But one of the we found that will be ISO 27001. And also GDPR compliance, also about the user data privacy is also a new emerging the data. We have to make sure the quality and safety is good on this level. And another part is the cloud level. Usually the people will not care about the cloud. One cloud is done. So do we have the contingency plan? Actually, the redundancy in the cloud architecture is also important that if we find one cloud is done, another cloud will immediately set it up and running and make sure the system is moving well, even one cloud have an issue. And the last one, the cloud management partner is also very important because we may need some partner in the cloud to 7/24 always monitoring every second, every minute. So this is very important. We have to have some cloud management partner to build up the cloud and monitor the cloud in safe and in good quality. Okay, so after I talk about the reliability and safety and the 5 important factors, actually, as something else is preventive analysis. So preventive analysis is once before something happened, because even I do all the tests, all the automation tests or report, it doesn't mean it's safe or quality is fully under control. So that's why we have to have a preventive action to make sure we always keep monitoring the system in very good shape all the time. As I said, the cloud alert system, monitoring system, checking system, and device offline alert, and the system offline alert, and the system monitoring portal. All these kind of things will be the preventive analysis and action from the project management level and the customer level. And next one will be when even I have preventive or we have 100% of safety and the reliability and quality checking, but still we may have some issue, then we have to have a contingency plan to make sure the system and the product is working fine, even we find the product or even some problem happening. For example, if we rely the system inside the cloud running, so if the cloud some issue done and not running anymore, do we have an intranet or we talk about the local control to make sure the system still running by the local control. So this is one of the contingency plan for the IoT system. All right, the last page, I would say, you see so many steps of the quality or contingency or preventive. I think more important, so we must have a very professional and a good teams to make sure all the step is running good. So let's say we have a product team, we have a software team, we have a cloud team, and we have a very good manufacturing team, and we have a top project team to make sure the project is running good, and the project is the automation testing is good, and the checking the record on the cloud is all passed by the project team. Also, we have an after service team to make sure the preventive or contingency plan action is doing well. All these teams will be involving all the safety and reliability of the IoT solution. Okay, so hope not too heavy to you guys, and I think that will be all about our job and we do the project in different area. So thank you, and hope the sharing will be helpful to you guys. Thank you so much.
Thank you, Mr. Alex Chen, for sharing us your valuable and practical experiences. Now, let us now invite guest speaker, Dr. Daniel Lun, Associate Professor and Interim Head, the Hong Kong Polytechnic University. His research interests includes wavelet theory, signal and image enhancement, computational imaging, and deep neural networks. Dr. Lun is a chartered engineer, a fellow of IET, a corporate member of Hong Kong IE, and a senior member of IEEE. His topic is surveillance video anomaly detection for smart system. Dr. Daniel Lun, please.
So thank you for the introduction. I'm Daniel Lun. I'm from the Polytechnic University. It's my great pleasure to have this opportunity to share with you our work related to surveillance video anomaly detection for smart systems. Yeah. Let me have a try this one. Okay, yeah. So we are a part of CAiRS, okay? We are from Project 5.2. So I'm the leader of this project, and then our team member, Tom, Dr. Zhang, Mr. Hong, Mr. Pan, okay? They are team member. Actually, most of the work that I'm going to present in this seminar, actually are done by them, okay? So I'm just one to do the presentation. So the first part I would like to talk about is our solution related to video anomaly detection, okay? And has been done for about 12 months up to now. And we have already got some results. And we are also looking forward to further research direction, such as the anomaly correction, okay? So I will also talk about this topic a little bit. So no matter whether you like it or not, so surveillance camera actually are everywhere. You can find surveillance camera in shopping mall. You can surveillance camera in airport, in office, anywhere, okay? So of course, this surveillance camera is not only for monitoring the activity of the society. A lot of people try to use them to do many smart applications, okay? In this area, actually, South Korea may be the leader, okay? Just in Seoul, in December 2020, they have already installed 75,000 surveillance camera, okay, just in one city. So they use them for different security, facility management, and safety, traffic safety applications. I think if you are fans of Korea drama, okay, you should know that there's a bridge in Seoul that people always want to jump off them, jump off it, okay, to commit suicide. So the South Korean government just aware of this problem. That's why they install an AI system on the bridge, okay, and then to detect if there's any people who look like that will commit suicide, okay, and then make the alert. So that kind of AI system obviously rely very much on the surveillance camera, rely very much about the quality of the surveillance camera. They always assume that the quality of the video obtained are perfect. They are good quality, that's why they can detect anything they want to detect. But what if actually the camera do not see the scene clearly? They will say if the video actually is not that clear. There are many reasons that the surveillance video become degraded. For example, it may be due to environmental reasons, such as haze, fog, rain, snow, or dust, okay? All these environmental factors can affect the quality of the video obtained from the surveillance camera. Although the effect is temporary, but the video taken in this kind of situation should not be used for any smart application because it will make wrong decision. And this kind of degradation can also caused by the aging of the electronic and mechanical component. The video can be blurry due to the shifting of the lens position. The video can be occluded by something due to the dirt on the housing or the lens. The video can be noisy, can have hot pixel, to be jittering, okay, due to bad wiring connection. All this electronic and mechanical problem, okay, can let the video to be degrade significantly. That kind of problem is permanent. So we need to ask the company to replace the camera or at least do some maintenance, okay, before we can use this camera again. And those videos also can be affected by some manual, by the intruder actually, okay. They intentionally want to do something on your surveillance video to make sure that it cannot operate normally. Okay, they just move the camera or spray paint the camera or even give a fixed video, okay, to replace the normal one. So there are many reasons for that kind of degradation of the surveillance video. Of course, if we know the video has problem, then we can do a lot of things. But how do we know the video actually has problem? You know, all camera, they are installed in a, for example, high up the lamp pole, maybe in different and remote location. It may not be easy for maintenance people to go to there to do the regular checkup of the camera daily or even monthly, okay? If it's annually, it's already a good practice. And the next solution may be we send all the video to a control center to ask someone to watch the video, okay, to make sure that video is okay. But if there are 75,000 cameras, how can you find a control center that can let you to see every camera, video from every camera, if they are okay or not? And also, some of these are kind of smart decisions need to be made on site. They say the video will not send to the control center. They will just make the decision within the camera. So in this case, perhaps you need to find someone sit inside the camera to check whether the video is okay or not. Of course, we cannot do so, okay? How about we install an AI viewer, okay? We use a machine, okay, that can replace a human being to monitor the video if the quality is good enough or not. Even if you don't do it in the camera, at least you need to have this AI viewer inside maybe the cloud, okay? When your video sent back to the cloud, let the cloud to do the detection. So it is the objective of our surveillance video anomaly detection project to develop such an AI viewer. This AI viewer can be on the edge, okay, on the camera, or maybe in the cloud, okay. So our objective is to design an AI model, an anomaly detection AI model, such that when we give this model some video frames, okay, so it will detect whether this video frame are normal or blurry or shaking, flickering, hazy, etc. There any kind of anomaly. Of course, to develop this AI model, the first thing we do is to have a training algorithm to train this AI model based on some objective functions. And then in order to develop this training algorithm, we also need to develop the database, which contain all the low-quality video and the labels in order to train this AI model. The challenge of this project originally, I thought, okay, is to provide the accurate assessment in different environmental conditions, okay, to minimize the computation resource requirement for edge implementation. Originally, I thought this is the major challenge of this project. However, when we start the project, we immediately found that to construct this data set may be the even bigger challenge. I think in academic, okay, we are from academic. When we do any AI project, AI research, database or data set, never a problem. We can always find a lot of data set on the web, okay, developed from different research group, okay. We can just download them, and then we can make use of it to develop our training algorithm, to develop our AI model. But for real practical AI system, the problem usually is very specific. You cannot find the data set, okay, or you cannot directly find a data set in an academic that can let you to train the AI model you want to solve a real problem. So the first thing you need to do in this project is to construct this data set. So we try to divide our work into 2 stages. First, we try to look at the anomaly that can be detected with only a single image. Okay, because we know that if we want to develop a video-based data set, it will be even more complicated. So we try to look at those anomalies that can be detected with only single image. So we develop a image-based data set. Okay, so we look at 2 particular anomalies in surveillance video. They are blurring and partially occluded. For that kind of anomaly, we can detect them with only a single image. That's why we can only develop a image-based data set. We further divide this kind of anomaly into 5 classes: a normal one, and environmentally blurred due to haze, dust. Okay, there's just some temporary effect. And we can have another class of defocus blur. Okay, that is the camera actually is defocused. That's why the video become blur. We have a class of partially occluded, 2 classes of partially occluded due to dirt and due to spray paint. Okay, we try to detect these 5 classes of anomaly because they are common, and also they can be detected with only a single image. So for these 5 classes of anomaly, okay, we need to obtain many images, both positive and negative sample, okay, for our data set in order to train the AI model. Some of these images can be found from the literature, from some existing data sets, okay, such as the normal image, normal surveillance image, some of the environmental blur image, okay, such as the hazy image, foggy image, raining image. Those images can be found from the existing data set. But some images, okay, they're so specific, we may even need to capture them by ourselves, such as the spray paint image, such as the dirt image. We need to capture them by ourselves, okay, in order to prepare enough test sample. However, if we really need to take those pictures, okay, it may be very time consuming. For every category, at least we need to prepare, say, 2,000 images. So if we need to take the image one by one, then we need to go to 2,000 different places to gather all these samples. So it's not possible, okay, to follow the time frame of our project. So that's why we also need to use some software approach to synthesize those training image, okay. These are the image, okay. In this slide, these are the image that we taken by ourselves, not by software synthesizing, okay. So actually, we use a plastic board, and then on this plastic board, we spray some paint, okay, different color of paint, okay, on it, okay. So you can see some red color paint, yellow color paint, etc. And then we put this plastic board in front of the camera and then take picture. We go to different places in Hong Kong to take this kind of picture, but they are not enough. So that's why we also rely on software synthesizing. So, particular for spray paint image, we develop a software model that can let us to generate this kind of spray paint image. Perhaps I'm not sure it's the right time for me to describe all this mathematical formulation, okay? But perhaps we just talk about briefly about how we generate this image. So first of all, we generate a Gaussian distribution mask, okay? This mask will control, okay, how the burn effect, okay, of the image after the spray paint. So we design a spatially varying Gaussian blur function. This function will convolve with our original image such that the burn effect will follow the Gaussian distribution described at the top of the slide. So you can see that in the middle of the slide, there's image called IB. IB is the bird image. In the middle of it, okay, it is more blurred than outside. Okay, so the blurring effect will follow the Gaussian distribution. And then we use a transparent function, okay, such that we can add the color onto it. Okay, so the image on the right-hand side, okay, is the image that we add the color. So this result we simulate when we spray the paint by a single shot. Okay, but normally when we do the spray painting, we will do the spray paint continuously, not by just one shot. That's why we develop a multi-shot model. We create a lot of Gaussian function at different positions. We add them up together in order to create a pattern. At the bottom of the slide, okay, you can see this simulate when we spray the paint from the top left corner to the bottom right corner. And then you can see when we apply this mask into the spatial varying Gaussian function, then it will generate an image that will blur in the middle part of the image. Then we add the color to it. So the image IN is the final result. Okay, that's similar. We spray the paint continuously from the top left-hand corner to the bottom lower-hand corner. So by controlling different parameters of this model, then you can generate different kind of spray paint image, different color, different size, different level of transparency. So these are the results. Okay, on the first column is the image that we generate. The bottom column is the image that we capture, okay, with the plastic board. You can see that actually they are very similar, okay. So based on these images, we can train our model, okay. We use the software-generated image to train the model. We use the real capture image to test the model, okay, in order to see if our model, if this kind of generated image is good enough. Not only the spray paint image, the dirt and the focus image are also synthesized using the software approach for training the model. So as a result, a data set of 7,500 images is constructed in this project. Every category, normal, defocus, environmental, dirt, spray paint images, we have about 1,200 images for training, 200 for validation, 100 for testing, altogether 7,500 images. Yesterday, I just got an email from a team member. They have even further increased the number of images. Now it's about 10,000. Oh, the slide may be then too small, okay, for us to see the numbers. Now, we try to evaluate the performance of the data sets, okay, in two stages. First, we look at only 3 classes first. Only look at the normal one. We try to classify the input image in the 3 classes: normal, environmental blur, and the focus blur. We focus on the blurry image. We try different existing AI model, okay, for that kind of surveillance video detection, anonymity detection. So if you can see the number clearly, yeah, okay, it's okay to me. Yeah, you can see the number clearly. You can see that the accuracy of the classification can be up to 90-something%. Okay, because the problem for 3 classes is still relatively simple. Okay, we just need to differentiate between normal image and environmental blur image and the defocus image. The model that we use, actually, the size is not too big. The smallest one may be only a few 100K, and the performance still around 90-something%. So let me take a look at the result of this one. Okay, the ResNet is 18, which can achieve a accuracy of 95.6%. So these are some of the classification results. For the clear image, for example, we can achieve accurate prediction. The probability of clear is over 98%. And then Some of the situation may be a bit difficult. For example, such as the middle one. Oh, you can see it. Okay. So it's the middle one, the first row, second image. Okay, that blurry image actually is not only blurry, it's also hazy. It's a blurry image taken in the hazy weather. Okay, so we need to report accurately, because if it is blurry, it's a kind of permanent defect of the surveillance system. We need to have some kind of maintenance and even replacement of the camera. So that's why we need to classify it accurately. It should be blur, not haze. Okay, so the system accurately estimate or classify that image is blurry, not just hazy. Then we start to do the 5-class detection level. So now we try to classify our image into 5 classes, including the partially occluded image due to dirt and spray painting. The accuracy now at the moment is about 80 to 83%. So we found that most of the error come from the spray paint image, because most of the existing model do not really make use of the color tone of the image to differentiate it is spray paint or not. As you can see, the spray paint image actually is so different from the hazy image. But the existing model of always classify the spray paint image as hazy, because they don't really use the color. So that led us to do further research in this area in order to look for a better model that can pay attention to the color of the image in order to differentiate spray paint image and the hazy image. So this 83% is our current accuracy. I think later on we will have better performance very soon. Right. So now if we can identify the kind of anomaly of our surveillance video, then what else we can do? We can report to the user saying that your video is not good. You should do some maintenance and replacement. However, if we do in this way, that means that that camera cannot be used for a long time. At least cannot be used until the camera is replaced or maintained. How about we do something more? Okay, even we know that the video is not good enough. Can we correct the anomaly, or at least minimize the effect of the anomaly in the video while waiting for the maintenance? In this case, we can still use the video for a smart application, at least for some while. So anomaly correction actually is closely related to a traditional research area, video and image restoration. Okay, for example, for a rainy image, now we have a lot of methods for de-raining. For the hazy image, actually there are also many methods for us to do de-hazing. So actually there are a lot of solutions we have right now that we can correct the anomaly. Okay, we are not saying that we are going to just use the that kind of video forever. We just use it until the maintenance. Okay, when you replace the camera, then we can use the true video. But before you do so, can we correct the anomaly and then make use of the video to continue this smart application? Our group actually has done many work in video and image restoration. Here I just want to describe 2 of our works, okay, in this area. They may be useful for anomaly correction. The first one is about image separation. You know, if you look at those images with dirt, those dirt, okay, if the dirt is not too thick, actually you can also see the background, right? It's only partially occlude the background, but actually you can see the background. The dirt just seems to be another image superimposed on the original background. So if I have a way to separate these 2 images, to separate the background image from the this unwanted image, okay, the dirt image, then we can get back the original background, okay, while removing the anomaly. The problem now becomes what we call the blind image separation. Okay, Why blind? Because we don't know the dirt, we don't know the anatomy. Okay, the pattern of the anatomy is not known. That's why we can only separate them without this knowledge. That's why it's a blind image separation problem. Actually, the problem has been studied for many years. I still remember that when I was doing my PhD, there were already people doing this problem. However, recently we have some data-driven approach. We have some very powerful deep neural network, okay, that can help us to further improve the efficiency and accuracy for that kind of blind image separation. We have also some work in this area, okay. One of the work, okay, in this area, it's like this. Now, if you look at this third image, okay, or unwanted image, we will always find that they are blurry, right? Usually they are blurry because they are not the target of your video or your image. Usually the background will be focused, will be clear, and those dirt or the unwanted thing, okay, they will blur. So many existing approaches make use of this as a cue to differentiate between background and the unwanted component. However, even for the blurred image, you can still find some edges over there. You can still find some gradient, strong gradient of this unwanted component. Although they are blurred, in general, there's still some soft edges. This kind of soft edges, okay, for the traditional method, they will consider it as the background because it's sharp. Okay, this will consider the background leave behind in the image. So that's why traditional method always has a lot of residue of the unwanted component, even if they can do the separation well. So we developed a method to take care of this problem. Due to the time, I think I will not go into the detail, okay, of our method. I just want to describe our strategy. Our strategy is just like that. First of all, we use a very aggressive approach to try to remove as much as possible the unwanted component. Even it will remove the background, it's okay. We use this aggressive approach to remove the unwanted component as much as possible. And then, based on this, okay, we use another process. Okay, we use for those of you doing AI research, you should know what is GAIN. Okay, the generative adversary network. Okay, GAIN can allow us to regenerate. Okay, to generate something. Okay, from our training. So this GAIN will try to regenerate the missing background. So first of all, we try to remove the background, remove the unwanted component as much as possible, even if we remove the background. And then we use a GAIN to regenerate the background, okay, based on some large data set for training. So this strategy we call the regeneration strategy, okay, for image separation. Okay, there are many details here, but I just skip them, okay, due to time limitation. Let's directly go to the result. Okay, so this is the image. Okay, at the moment we still have not applied it to anomaly detection. We try to use it in another problem for refraction removal. Okay, but the problem is similar. So on for the image on the left-hand side, so actually the image is synthesized with two images add together. The background image add with a blurred unwanted component. Okay, they also look like an image. So the first step we are going to do is to use an aggressive approach to remove as much as possible the unwanted component. So that's why the thing that was originally blurry, okay, they are now removed. However, in this case, the background will also, some of the component, the background will also be removed. So actually, you can see, if you can see the whisker of for Doraemon, okay, actually has been removed. So it is unavoidable because it is an aggressive approach that will let us to background even removed. Then the second stage is gain. We regenerate the background component. So B final is the final result. You can see now it's very similar to the ground truth. This is a synthesized image. That's why we have the ground truth. Okay. Now let's have a try of the real image. On the right-hand side, they are the real image. This image, we took it through a glass, such that the image contains a reflection from another scene. Okay. So again, the first step is an aggressive removal step. This is our initial guess. We try to remove as much as possible the unwanted component. So that's why those things that the reflection of the image are totally removed. However, in this case, the background becomes blurry. Okay, if you zoom in the red box, you can see the detail there actually are very blurred. That's why we need to make use of the second stage, the gain network, to help us to regenerate the background. Okay, to generate the details of the background. So the final result, you can see the background recovered. Okay, the detail of the background recovered. So this is one of the work that we think can be used for anomaly correction. That is, say, if we have some dirt in our image, can we simply separate the background from the dirt using that kind of approach? If you're interested in the detail, you can just take a look at our paper published in this journal. Another research area that we have done recently is about low light enhancement. You know, in video surveillance, it is inevitable to have variation in lighting condition. Okay, that kind of variation sometimes is lateral. Okay, when you go from daylight to not to dawn or even at night, okay, the lighting condition will change. And some situation of this kind of lighting condition change are accidental, due to your camera, due to some intentional attack, okay, from other people. They just try to make the environment become dark to make sure that you can't see anything. So of course we can detect this kind of situation to ask for maintenance, switch on the light, replace the camera, etc. But can we do something while waiting for maintenance? Can we let the video or image to be bright again? Okay, we let it bright again, and then continue to do the smart application. Now, if the environment suddenly becomes very dark, the video capture will have a very low dynamic range. Okay, in normal situation, we may have you use 8 bit for every pixel, but when this is low light situation, maybe only 4 bit, then maybe only 16 brightest level. Okay, so if you want to correct this video to make become bright, okay, there are a few things you can do. The first thing is you can adjust the aperture of the camera to let it bigger so they can absorb more light. But in this case, you need to reduce it will reduce the depth of field. In this case, the object not in the depth of field will become blurred. Or you can adjust the sensitivity of the sensor, increase the ISO value, but it will introduce strong noise. Now, these two approaches, you need to go to the camera to adjust this setting. Okay, if the camera is so far away, you may not have a way to get to the camera to adjust aperture or adjust its ISO value, and then you have to process the image, process the video. You may adjust the brightness of the video directly using some image processing approach, but in this case, you will lead to some kind of a condensation effect, particularly in the smooth region. So there are many other ways you can do. One of the ways is to use this kind of low light enhancement method. Okay, this is one of our solutions on low light enhancement. So on the top left-hand corner, the image is actually very dark. So based on our method, we call it the DLN, okay, Deep Lightening Network. We try to light the image to make it to be similar to the original level. Okay, you can see the image on the right hand side. They are the zoom in of the red box. Okay, actually the DNA approach gives a result very similar to the ground truth. That kind of low light enhancement method, in fact, is very similar to the super resolution problem. I think you know what is super resolution, right? We have low resolution image. We try to make a high resolution image. That's why we need to do super resolution. Okay, super resolution is to increase the resolution in spatial domain. Now the problem is not like this. The problem is we want to do super resolution in the dynamic range of the image data. Originally, the image, because it's dark, that's why each pixel can only be represented by only 4 bits. Now we want to do a super resolution to let it to have 8-bit information. So it's also a super resolution problem. That's why we can also make use of some super resolution technique, okay, to deal with this kind of low light enhancement problem. This is the deep lighting network that we use, okay, or develop. Inside it, there are many things inside it that take a long time to explain. I just want to point out one important component is the low light back projection model, LBP. Okay, this one, okay. Lightning back projection model. That kind of lightning back projection network or back projection network has been used quite successfully in different super resolution problems. We borrow this idea into the low light enhancement problem because actually they are also a super resolution problem. The idea is very simple. Assume that you have a very dark image, okay, low light image. Traditional approach, try to train a model that will enlight it, okay. That is the upper red arrow. That upper red arrow try to enlight the low light image to a normal image. However, due to many reasons, that the lighting operator may not operate correctly. It is the case of the existing method. That's why the enlightened image or the estimated normal image actually is not really the same as the normal light image. There are a lot of difference. Traditional approach, we just leave it there without doing anything. So we try to make use of the super resolution technique and provide a feedback, okay, from the quality of the estimated normal light image. We compare the, we use another darkening operator to generate a low light image from the estimated normal light image and compare the difference. That difference, the difference with the original low light image. So the difference of them actually encode some information about the inefficiency, about the lightning operator and the darkening operator. Then when we train another lightning operator in order to estimate the true residue between the real normal light image and the estimated normal light image. The CAiRS approach actually has been used quite successfully in the traditional super resolution problem. We borrow it into the design of this low light enhancement problem. So this is the model. As I mentioned before, there's a lot of detail over here. That's why perhaps due to time limitation, I think I better just give you the final result. So this is some result from the simulation. Okay, so that's why we have a ground truth. We compare our method with different approaches. Okay, we generate the result actually quite similar to the ground truth. So for the detail, perhaps we can also take a look at our paper. And then the previous one, okay, for this one, I would like to zoom into some particular region and see the real difference between the proposed one, the one that we developed, and the one from the existing literature. So I'm not sure you can see a small square box in the middle of the image. Okay, and then when we enlarge it, you can see the difference between our approach and the traditional approach. So DRN is our approach. So traditional one usually contain a lot of defects, such as noise, such as the blurring, okay, effects, and then using the feedback, okay, approach that we have developed, then the DRN result is much close to the ground truth. Right. So let me just summarize what we have discussed. So the quality of surveillance video, okay, should be monitored because we use it for different smart application. If there's any problem about the quality of the surveillance video, it will affect the accuracy of the smart decision made based on the video. And we try to develop an AI viewer for putting into the edge system or in the cloud to detect the blurring and partially occurred anomalies in the surveillance video. And whenever we detect the error, then we will alert the user for maintenance or replacement of the camera. And then we also suggest that the effect of anomaly can also be minimized by different video image restoration technique. And I have suggested two methods, image separation and low light enhancement technique, to be the solution for restoring a surveillance video degraded by dirt and lightning variation. So that's it I want to say. Okay, thank you very much.
So thank you, Dr. Daniel Lun, for your remarkable presentation. Kindly remind our participants to scan the QR code if you have any questions that you'd like to ask Dr. Daniel Lun and Mr. Alex Chen. Thank you all the speakers and their inspirational sharing. I hope that all of you will find this sharing inspiring and exciting. In the following time, I would like to start Q&A session. Let us see what our participants is asking. The first question is asking Dr. Daniel Lun. The question is related to the image database. So given the 3 or 5 classes anomaly detection, what issues were considered in the image database construction, such as the image quantity, quality, diversity, etc., etc.? And what is the hardest part to create the database?
Actually, I have already talked about it. Okay, you know, in real life, okay, we solve a real life AI problem. The data actually is not easy to get because usually they're very specific. Just like this one, we want to obtain the data for a camera that will generate video with anomaly. However, most cameras will operate normally. And then if a camera generates some low quality video, nobody will keep it. They will just trash it, throw it away. So that's why to obtain that kind of data is very difficult, particularly the negative sample. And this is the reason why we need to use some software to generate this selective sample. We need to capture our own image for this selective sample. You know, if we want to have a very accurate system, normally we need to have more than 10,000 images for our data set, or even more. So there's a lot of effort for collecting this kind of data. A lot of them are very manpower intensive. Really.
So thank you, Dr. Daniel Lun. I've got another question asking Mr. Alex Chen. It's about the IoT system. So for IoT system solution in general, how to consider the application usage when some sensors, for example, infrared detection sensor, might not function 100% correctly. In real world, that might cause safety issues. So, Mr. Alex Chen, please.
Yeah, I think this is a very good question. It's about the sensors, the accuracy or the technology, the accuracy. That's a very good question because we encounter so many projects. The customer expectation is the motion sensor. Can I get the motion sensor in the meeting room? So if after maybe 1 minute, so nobody here, so the light will be turned off, or the AC will be turned off automatically. And the answer I will talk to them, I will let them know is cannot. Not 100% cannot, but it really depends on what product and what technology you are using. Because, for example, you talk about the motion sensor or infrared. So we have different kind of motion sensor. We are using the passive infrared or the active infrared, or even we have a microwave or different kind of motion sensor. We have a technology. So different technology with different characteristics. So that's why it really depends on the application. What technology and what product we put on, and to meet the customer expectation. This is very important. And another part is the installation. As I mentioned before, my PowerPoint, if the motion sensor or the product, the installation is not correct, the infrared, the coverage, or the wireless communication range may have an issue. So that's why the difficulty of the IoT system or the smart solution, I think involves so many parts. First of all, the technology of the sensing, and also the product quality, and also the wireless range or the wireless quality. And another thing is the workmanship of the installation is proper as a high technology product. So all these things will be consist of the safety and the quality, as you mentioned, of the application.
So thank you, Mr. Alex Chen. Thank you all guest speakers for sharing your specialized concepts on reliability and failure analysis for electronics. Ladies and gentlemen, at this moment, we are very honored to have Professor Winkle Yung, Center Director and Executive Director of CAiRS, to be here with us today to offer a closing remarks before we end the webinar. Professor Yung, please.
Thank you, Tom. Thank you for all the audience who have shown up in this morning webinar. I was told by the organizer that as of yesterday, there are 260 registration for this particular webinars. That means a lot of people from academia, from the industry, they are very pumped to this particular topic, reliability and failure analysis for electronics. And in the market, I mean, even in the academia, it's very rare that we have this kind of topic being discussed in the public domain. So in the past, CAiRS has been organizing many webinars, including many topics related to AI, big data, reliability, and modeling for electronics, and a lot of application as well. For audience who may like to see those topics that we have been discussing so far, you are welcome to visit our website. You just type in CAiRS. I think the first two, or even the very first one, pop up in the website search will be CAiRS, okay? Well, to conclude, CAiRS is here to help the local industry to apply AI, big data, reliability modeling in their business, in their research, in the applications. At the moment, we have over 27 industry collaborators who are there to apply our research findings. Now, altogether, we have 15 projects running in parallel, and Dr. Daniel Lun is one of the project leaders. Apart from him, there are more than 19 professors from Purdue and from University of Maryland, something like a consortium working together to develop some technology based on those or related to those 15 projects. So we always welcome comments, and if you have any interest to have discussion with CAiRS, please go to our website and contact us. Finally, I'd like to thank, firstly, our colleagues from University of Maryland, Dr. Atta and Dr. Oxterman. Now, even though now they should be sleeping, on bed in US because we are 12 hours apart. Well, but I'd like to give them a heartily thanks. UMD has been a great partner with CAiRS in the past and in the time to come. I also want to thank Alex, the GM of Tronical Technology Company Limited, who has been applying our research findings in their IoT devices and systems. I would like to thank my colleague, Dr. Daniel Lun, who spent a lot of time leading the team, who has done so much fruitful research with findings that are readily applicable to the industry. All in all, we are helpful and we are here to help your business and your research. So without too much further delay, I would like to close this webinar, and we'll be having next one starting next Wednesday. Starting November, we will have almost weekly lecture. I think most of them are on Wednesday morning. Please come to our website and you'll see all this invitation to join these upcoming lectures and webinars. So thank you once again for joining us this morning. Have a good time and good day. Thank you. Bye-bye.
Thank you, Professor Yong. Again, thank you to all our guests and participants for joining us today. And most heartfelt appreciation to all our speakers, technical support, and supporting organizations for supporting the webinar. I hope all of you found the webinar beneficial and valuable throughout the webinar on the topic of reliability and failure analysis for electronics. I wish you all a pleasant day. Thank you. Goodbye.